All right, this is the 6B.4 notes for probability with and, conditional probability, and contingency tables. I am going to go ahead and cover this material on a full video for you to watch right now between now and our next class meeting. We will still move this homework assignment to be with the 7A material as well as the quiz for week 6. But I want you to make sure you watch this before the first class next week, because if you have any questions, I would like for you to ask those towards the end of that class. So let's talk about this. So probability using and. Probability of A and B means that you have to be in both A and B at the same time. That's the gist of it. This is the little symbol for that. That's the overlap intersection. So let's look at this first example. It says there are 10 red balls in a bag numbered 1 through 10. So I'm going to imagine just having R1, R2, R3, R4, R5, R6, R7, R8, R9, and R10. I'm just drawing out our space. 5 green balls numbered 1 through 5. So green 1, green 2, green 3, green 4, and green 5. So that's how much we have. And we're looking at the probability of selecting a ball that is red and even. Now we could actually see that directly from what we have listed there, because they have to be both red and even. So I want to just go ahead and get that answer. So red even would be the 2, the 4, the 6, the 8, and the 10. So that's 1, 2, 3, 4, 5 of our numbers. I'm red and even, red and even, red and even, red and even, red and even. So that's 5 numbers out of the total number of balls in the bag would have been 15. So if we reduce that down, that is 1/3. Now you could also visualize this by looking at a Venn diagram, where and you don't have to draw these. This is just to show you a visualization. I'm going to need to make that overlap a little bigger. And the way you could set this up, just so you could see how to do a Venn diagram if you're ever curious, we would let red be this circle and even be this circle. So the and part should be where they overlap, that stuff in the middle. So if we look at our red circle, if you're red and even, you go in this little overlap. So red 2, red 4, red 6, red 8, red 10. That's that 5 elements that were in both groups. If you're a red with an odd number, you go out in the red circle. So red 1, red 3, red 5, red 7, red 9. If you're even, you also go in the second circle. So there are some greens that are even, but they're not red, so they wouldn't be in that overlapping part. So like the green 2, the green 4. Now you might be thinking, where would the other ones go? Well, they are not either, they're neither red nor even, so they go out in kind of our little universal space, which is not in our sets that are our interest sets, but it is still part of the whole universe. So like green 1, green 3, and green 5 would just be floating out here outside of those circles. So if you ever wanted to draw your own Venn diagram, that's kind of how we do it. And then this is the answer. Remember, it was that overlapping part. So that's just a visual to go along with just what we counted. All right, let's look at our next part of this. So what is the probability of selecting a ball that is red or even? Okay, so this is or. That's different. Remember, our or formula you had to think if there was overlap. And there's definitely overlap here. So when there's overlap, when there's stuff in both groups, we do the probability that I'm red plus the probability that I'm even minus the probability that I was red and even. Okay, so red and even. So red, there were 10 out of the 15 balls that were red. Even, well, there's 1, 2, 3, 4, 5, 6, 7. So there's 7 evens out of 15. And we said that we double counted, remember, 5 if we do it this way, because we would have counted the evens, the 7 evens includes those 5 reds that we already counted in this group. So then when we work this out, that's 17 minus 5, so that would be 12/15. If we reduce that down to a lowest fraction, divide both by 3, that would be 4/5. So 4/5. All right. Now we're moving on to, so that's the and problems. You're just looking for that overlap, and then we just threw the or in there just to make sure we're paying attention. So conditional probability is our second topic, and it is defined as the likelihood of an event or an outcome occurring based on the fact that you already know something else about your outcome. So let me explain this the best way that I know how. If I was to slide a poker card, just a standard deck card, face down across the table to you, and I said, what's the probability that it's a heart? Well, if you have no information about that card, you would have said, well, there's 13 hearts out of 52 total cards. You would have told me it was a 1 in 4 chance. But if I tell you what's the probability that it's a heart, given that you already know it's a red card, well, that changes things because now you're no longer talking about the whole deck of cards. We already know it's a red card. So that takes us down to half the deck. So that's 26 cards. And there are still 13 hearts out of 26. So now my probability is a half. I have a lot better chance of it actually being a heart if I already know that it's a red card. So that's kind of what these probabilities are. So meaning something has already happened to narrow down the possible outcomes. So our denominator will not be total possibilities when we do conditional probability. The denominator will be the thing we already know. We know something about the item or the event. So you only have a subset of a total sample space to select from. So again, we're not picking from the whole sample space or the whole total, like how many marbles do we have? We're going to pick specifically from something we know about that. We're going to split it into a smaller group. And a lot of times you will see this word used to indicate you're doing conditional probability. It's the word given. So they'll say, what's the probability I have a heart in my hand given I know it is a red card? So notice they're telling me you already know it's a red card. All right, and this is the formula for conditional probability. It looks very complex, but I'm just going to tell you how to do these by piece because they're not very hard. This formula actually looks harder than the process is. So this is the actual word given in symbol form. This says probability of A given that I already know B has occurred. That means, okay, probability of a heart given it's a red card. So B would have been the red card in that scenario. What we do for the numerator is you find the probability of both. So how many cards in the deck are both a heart and a red card? That would go on top. And then how many cards are red? Because remember we said we already knew that out of all 52 cards, we know we have a red card. So that's the probability of the given part. So your denominator, which is total outcomes, is no longer the overall total, but the total of the subgroup that has already been determined, and your numerator must come only from this subgroup. So let's look at some examples. So it says a survey asked 100 people, what is your favorite type of movie? 33 said they like comedy, 60 said they like drama, and 11 said they liked comedy and drama. So we know probability, I'm just going to write some of these out. Probability of comedy would have been 33 out of 100 total people. Probability, because they told us there was 100 people surveyed, of drama would have been 60 out of 100. And I could reduce that if I want, but right now I'm just showing you the probabilities. Probability of comedy and drama would have been 11 out of the 100, okay? So given that a person likes drama movies, what is the probability they also like comedies? The condition that we know is we absolutely know the person we have selected, they like dramas. So we're only going to choose from this group. The drama group, okay? So you are selecting only out of the 60 people that was in our drama group. So that's the 60, that's the denominator. Out of that 60, how many liked comedies? Well, those are the people who are they have to like drama, so they also have to like comedy to be in that group. So they would be the and condition. That's going to be 11. So that would be my numerator. So our probability of I like a comedy, given that you already know I like a drama, is 11 people liked both out of 60 people who liked drama as their base. So it's 11 out of 60. So that's how you do it. You stack what is the given condition? That's your number in the bottom. What is the group that has both conditions, comedy and drama? That goes in your numerator, okay? Now, the formula back on the other page showed you to put the probabilities in there. They said the probability of comedy given drama was probability of both, which is and. over the probability of just the drama. So if we write that as the fraction form, it's a little bit more complicated than just talking through it. This is 11 over 100 over 60 over 100. And you have to know what to do with fractions there. You have to multiply by the reciprocal of the bottom instead of dividing. But that's how you get the hundreds cancel, and it's just 11 over 60. So the formula does work. It's just more thought-provoking than you really need it to be. If you just know how many are the people that we actually know for a fact, we know that we're a drama group, and then how many like both things that we're talking about, then you've got your fraction directly, okay? So let's do another one. A card is drawn from a standard 52 card deck. What is the probability that the card is a king given, which means I already know the card is red? So when we think about this, we need to only do red cards in the bottom. So only red cards in the deck. On the top, we need them to be red and the thing I'm looking for after I know it's red, which is king. Okay. So red cards are half of a deck. So instead of 52 cards, that would be 26. There are 2 red kings in a deck of cards. There's a king of diamonds and a king of hearts. So these 2 guys right here are the only 2 that meet both conditions. There's 2 cards. So out of the red cards, there are only 2 kings. So that would reduce down to 1 out of 13 if we wanted fraction, but they want us to go to decimals. So you can either just divide 2 divided by 26, or you can divide the reduced part. And then 1 divided by 13 to 4 decimal places, we 0.0769. So 0.0769. So there's about a 7.69% chance that if you pick a card and you already know it's red, it's also going to be a king. Okay. All right. And then that leads us into our last topic for the 6B.4, which is the contingency tables. We're going to be doing a lot more of these as well on our next class meeting. So this will get covered again pretty heavily in the false positives and false negatives section in 7A1. So contingency table is a way to display data in relation to 2 different variables that may be contingent or dependent on each other. In other words, there's 2 ways to label a specific category. Like you are a female doctor and you also have you're a family practice doctor. So you have a gender, essentially was what the rows are in that table. And then they have the type of doctor you are as the columns. So we can use these tables to help us determine probabilities that are or, and also conditional. So we're going to first talk about how do you fill in missing values if you have a contingency table that is not complete. So you have the total number of doctors, since this is these look like doctors that are in a practice possibly. So this is the total number of the people in our group. That's that bottom right corner. This is total females, this last piece right here, which means C should be total males. So I'm just talking about these pieces when I say that, okay? This is the total family practice doctors. This is the total pediatric doctors. And this is the total orthopedic doctors. So these total columns and rows are for their specific columns or row. And then the one in the bottom right corner is actually the sum of all the 26 plus C should equal 50, and so should D, E, and 17. They should also add to 50. So one way to get started in a table like this is I see that I can go ahead and get the total for the males. If I know I have 26 females out of 50 total participants, then I can do 50 minus the 26 to know the number of males, which will be 24. So that one is 24, okay? And then I can find this A, because I know all the numbers in this row except for A. So A plus 10 plus 7 should equal 26. So you could actually write that out somewhere on the side if you needed to. And we're solving for the A. So we're going to take that 10 plus 7, which is 17, and we're going to subtract it from 26. And that tells me that A is 9. So I can write that in. That helps me get D immediately because 9 plus 5 is 14. So you're just working your way through these columns and rows. 10 plus 9 is 19. And 7 and 17. Okay, so right here, this is pretty easy. 17 is the total. There's 7 here, so this has to be the difference. It is 10. So you can write out the formulas if you need to, or you can just use your calculator. So once you've got the whole table filled in, we're going to ask some questions. So the first one is, what's the probability that a randomly chosen person is a male? So that is a singular event. It's not an and or an or. It's not a given anywhere. It's just probability of male. So probability of male should be total males, which is 24, out of total doctors that we had, which was 50. And then we usually want to reduce these. So if I divide both of those by 2, that would be 12 out of 25. So there's 12 out of 25 chance the person I pick randomly would be a male. Find the probability that a randomly chosen person has a family practice. Okay, probability of a family practice, again, not an or, not an and, not a given, just what's the probability you have a family practice. So the total number of family practices were 14. Let me make sure that doesn't look like a 19. So 14 out of 50 total doctors. And reducing that again by 2 would be 7 out of 25. Okay, so there's that one. Now let's talk about how we can use the and or conditional probabilities to do the probability we need in a contingency table. So when finding P of A and B, both or all of the criteria must be met. Determine your total possible outcomes for your denominator, and then we find the intersection of our column and row that we're talking about. So if I wanted male and family practice, the numerator would be where they overlap, which is at 5. Okay, so 5 out of 50 would be male and family practice. When finding A or B, only one of the given criteria must be met. Your denominator is your total possible outcome still. From the total possible outcomes, add the total of each criterion, which is our or part, and then subtract the intersection so as not to double count. Okay, so we still use this formula, but we'll have to pick out the individual probabilities for each part. All right, so let's do some of these. Okay, so what is the probability of selecting? So this is the same table, just recreated without all the ink on it. What's the probability of selecting a male and family practitioner? So I kind of already answered that one. So male and family practitioner is the people who are in that overlap, which is right there, out of total number of people in the practices that they studied, which was 50. So that'd be a 1 out of 10. Okay, now let's do a different color just to make sure we can show it on our table easily. Pediatrician and female. Again, we're not doing given that, so we're still using our total 50 people. Pediatrician and female overlaps at 10. So the and statement says we get that overlap. That reduces down to 1 out of 5. Now let's do an or problem, okay? So I'm going to use orange this time. What is the probability that a person is male or a pediatrician? Okay, so to do that, we need to do the probability that they're male plus the probability that they're a pediatrician minus the probability that they were a male and a pediatrician, just that overlap part. So males, the total number of males is 24 out of 50. The total number of pediatricians is 19 out of 50. And we double counted. If you look at this row column relationship, we double counted those 9 people, okay? So we need to subtract 9 out of 50. I'm going to try and do that with maybe a highlighter instead. So maybe yellow. So yeah, when we look at this, nope, it's not going to let me do that. Let's erase that. I'll just circle it with the pen. So when we look at pediatricians and the male row, we notice that overlap was at 9. So total males, total pediatricians minus the double count. Okay. All right. And then what is the probability of selecting a person that is female or specializing in orthopedics? That's an or problem. Notice the ors there. They just didn't bold it for us. So probability of female or orthopedics, so ortho, should be probability of female plus probability of ortho minus the probability of female and ortho. Okay. So Probability of female, there are 26 total females out of 50. Orthopedics, there are 17 out of 50. And we double counted this group of 7, okay? So 7 out of 50. So I didn't do the math on that last one. I just realized that. So let's go back and answer both of these because we didn't actually finish the fractions on the last one. So 24 plus 19 minus 9, that was the C part. So that was supposed to be 34 out of 50. Sorry about that. Dividing both of those by 2 is 17 out of 25. And then let's do the one we just wrote out, which was 26 plus 17 minus 7, which is 36 out of 50, which reduces to 18 out of 25. So we actually have a little bit higher chance of getting a female or an orthopedic doctor randomly instead of a male or pediatrician. Okay, now I'm going to teach you how to do the given ones, and that is very, very, very specific. You have to only base out of the subgroup that you're looking at. So this first question, just what's the probability of selecting a female? So probability of female, we just did in the last one, which was 26 out of 50. We just need to reduce that. So that reduces by 2 to 13 over 25. Okay, so that was just a basic, no or, no and, no given, just what's a female. But this one right here says, given that we have a male, we want to know, is he an orthopedic doctor? So probability of, are you an ortho doctor, given that we know you're a male doctor? So when you do those conditional probabilities, we can only use the male total for the bottom, and the top number has to be male and an ortho, okay? So the total min is 24. So notice this is the only time our denominator is not going to be in the 50. It's when you do these given ones. So that would be 24. And then you look in that, since male's the row, we look in the row and we say, out of all of the males, well, how many were orthos? It was 10. So 10 out of 24, which we can reduce down by 2. That would be 5/12. Okay, let's do another one. So find the probability of selecting a pediatrician given that it is a female doctor. So they've kind of changed the wording here, but the given part is female. Remember, that's what goes after the bar. So we're looking for a pediatrician given female. That means that we can only use females as our total. And we'll want a female and pediatrician on top. So female total was 26, pediatrician females was 10. So this would be 10 out of 26, which reduces by 2 to 5/13. Okay, so that's how you do the conditionals. They stay completely either in a row or completely in a column because you can only use the total value of the group that you know we already have selected, which is the given part. All right, let's do, I think this is, we have 2 more, or no, 3 more, sorry. There's more of these than I sometimes remember. So let's do these last 3. So I'm not going to spend as much time talking about each detail. We're just going to read our numbers off. We're missing some totals, so we'll want to fill those in first. If we add that, that's 30. If we add that, that would be 23. I can triple check that that adds to 80 because that's 50 plus 30, so that's 80. 27 minus 16 is going to be 9, I believe, or is that incorrect? No, it's 11. I subtracted backwards in my head. So let's triple check that. 11 and 16 added together is 27. Okay, find the probability that a teacher has a bachelor's degree given that they are an English teacher. So we are only talking about English teachers. So bachelor's degree given that you're English teacher. So English teachers, that total is 30 people. Bachelor's degrees and English teacher is 20. And we're going to do simplified fractions for these. So this is 2/3. Find the probability of a music teacher. Notice no or, no and, no given, just music. So that's total music, which is just 23 teachers right here in this column, over 80 teachers total. And I do not believe that one reduces. What is the probability of selecting math or someone with a master's? So probability of math or masters. That's one where we'll need our formula. Probability of math plus probability of masters minus the probability that you have both. That's the overlap. So math teachers is 27 out of 80 total. Teachers with master's degrees is 35 out of 80. People who are math teachers and have their master's degree, we counted twice. So that is 11 over 80 that we need to subtract. So 27 plus 35 minus 11 is 51 out of 80. And I do believe that doesn't reduce, but 51 is divisible by 3, I think. Yeah. So as long as 80 is not divisible by 3 or 17. So we should be good. Always triple check those on your calculator. So what is the probability of selecting math teacher and someone with a master's degree? So we already figured that out. Math and masters was that overlap part. That's the people who had both. That was the 11, out of 80. So we already did that part as part of the last formula. So that does not reduce either. Find the probability that a teacher is a music teacher given they have a bachelor's degree. So we're looking for a music teacher and we already know they have a bachelor's degree. So that means only people with bachelor's degree are in our denominator. So if we look at bachelor's degree row, go all the way over, we have only 45 people to choose from since we know they have a bachelor's degree. Out of that row, only 9 of those people are music teachers. If we divide those both by 9, that would be 1/5. So there's a 1 out of 5 chance that if you know you have somebody who has a bachelor's degree as your selected teacher, then they also are a music teacher. All right, let's look at the next one. So this one's already pre-filled out, so we don't have to do any table calculations. Survey of 130, so that's our total at the bottom. College graduates conducted. Students were asked whether they were employed and if they were looking for a job. Find the probabilities as a fraction in simplest form. What is the probability that a randomly chosen student is not employed given that they're job searching? So not employed given that we know they are job searching. Okay, so only focus on job searching people, which is 45 total people. And not employed in that group is 19. And that is in lowest terms. So 19 out of 45. What is the probability that a randomly chosen student is not job searching given that they are not employed? So we're not job searching given that they are not employed. Okay. So out of the not employed people, there are a total of 41. They're not job searching in that group, which is 22. And that is also reduced, but you can triple check that. What is the probability that a randomly chosen student is just job searching? Notice no or, no and, no given. So just job searching is 45 out of the total, which is 130, and we can reduce that by 5 on each. So I know what 45 divided by 5 is, but 130 divided by 5 is 26. This would be 9. Okay, what is the probability that a randomly selected student is employed and job searching? So notice it's an and problem. Employed and job searching. The tables are lovely because an and problem is literally just where do they overlap. So employed and job searching. 26 out of 130. We can actually reduce both of those by 13. So that'd be 2 out of, I might be able to reduce it again, might reduce by 26. But if I didn't have my fancy calculator, which I don't right now, so 130 divided by 13 is 10. And notice right away, I noticed that reduces again to 1 out of 5. So make sure you fully reduce. And then what is the probability that a randomly selected student is employed or job searching? So we're going to have to do the formula with the overlap. So probability of employed plus probability that they're job searching minus the probability that they're doing both. Okay. So we already know employed and job searching. We just did that one. That I'm going to leave it in its 130 denominator form because that'll subtract and add easier. Probability of employed is 89 people out of 130. Probability that they're job searching was a total of 45 people out of 130. And so we have 89 plus 45 minus 26. If they all had the same denominator, that's 108 over 130. 108 is definitely divisible by 2. Actually, it might be divisible by 6. Let me see. It is 130 divisible by 6? No. So we can divide by 2 first. Let's start with that. So 54, then we can check if it goes more. 130 divided by 2 is 65. 65 is divisible by 5, but 54 is not. But what is 65 divided by 5? That's 13. Is 54 divisible by 13 is the next question. It is not. So you'll want to double check me on this one just because I don't have a calculator handy right at hand that tells me if that's fully reduced, but I believe that it is. All right, so last one. This one is blood types. So blood types are A, B, and O, and everyone has either a positive or negative RH factor. So they have a total of 362 people that they talk to, and they've been broken down into their blood type and positive or negative factor. So what is the probability of choosing a donor with O blood given that they're RH positive? And we are going to round to 4 decimals on these. So we want to have O blood given that the person has positive RH factor. So they're only talking about positive people since we know that their RH is positive. So that's 173 donors that are RH positive. And the O on that group is 28. So 28 out of 173, which we're going to turn into a decimal, is going to be 0.16, and it was 18, and it does not bump up because there's a 4 after it. What is the probability of selecting someone that is RH positive or AB? So probability of positive or AB would be probability that I'm positive blood plus the probability that I have AB blood minus the probability that I have both. Okay, so positive is 173 out of the total number of people. We're not doing a conditional probability. Plus AB is 30 people out of 362 total people. And the AB overlapping with the positive, that'll tell us our subtraction number. We're subtracting 8 people that got counted twice. So that's going to be 173 plus the 30 minus the 8. That's 195 over 362. Need to go ahead and get that into decimal form. That's going to be approximately 0.5387. It will round up, so 5387. All right, we have just a couple more parts. What is the probability of selecting someone that has RH positive and blood type AB? So we already did that, right? We did that in the last part for the both part. So positive and AB, that's the 8 people out of 362. They have both of those conditions. So 8 out of 362 is 0.0221. So about a 2.21% chance. What is the probability of selecting someone that has type A? So notice again, just a straight not or and or given. It's just A blood. So A blood is 126 people out of 362. So 126 people out of 362. 126 divided by 362. That would be 0.3481. All right, I hope that helps. And like I said, I will give you some time on our next class meeting just in case you have any questions about this.